Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about inference for the mean difference, which is using paired data. All right, so our first example, I want to test a new weight loss drug. I recruit 10 randomly selected subjects and weigh them before the experiment, and then again after they have taken the weight loss drug for 30 days. The results are below. How can I test to see if the drug lowered their average weight? All right, so this is going to be a paired t-test. We are testing the average difference. With paired data, we have two samples that are dependent on each other. They're coming from the same population. All right, in our average difference, we're going to use the symbol mu d. We look at the difference between the two sets of data. So we're going to take the two samples and combine them into one sample by subtracting, right? So we're going to put our data into list 3 by doing list 2 minus list 1 to find the difference. And we're going to do a one sample t-test or t-interval on the differences, all right, using list 3. Sometimes if they give you the data, they might give you the other list, like they might also include 3 lists where they just give you the differences. So you could just go ahead and put those differences right into list 1. Or they might give you the mean difference, the average difference, and the average difference is standard deviation. All right, so state, we're going to have our null and alternative hypothesis where mu d is equal to a number. This is typically 0, and our alternative would be mu d is less than, greater than, or not equal to a number. Mu d is almost always going to be your after minus your before, and you're going to need to define that, your parameter. Plan, we need to check our conditions. We should be working with paired data. It needs to be random, the 10% condition, and then normal conditions. Either it's coming from a normal population distribution or the number of differences is 30 or more, and we can use the central limit theorem. All right, so paired data means the data recorded on the same individuals before and after. We're going to run either a one sample t-test or a one sample t-interval. In your calculator, it's just going to be t-test or t-interval using the differences. And our degrees of freedom is going to be n minus 1. Our conclusion is going to be the same as our one sample t-interval or t-test, and it needs to be in context. All right, so the average difference between blank and blank is, and we want to make sure that we don't say the difference in averages, because that would be a two sample t-test or t-interval. All right, so our match pairs t-test, a random sample of 12 sixth graders was given a memory test. They were then enrolled in a 9-month chess program. At the end of the program, they were given another memory test. The researchers were interested to see if learning chess would increase memory. So I have the pre-test and the post-test, and we wanted to see if it was increasing. So we're going to state mu d is the true average difference on the memory test, post-test minus pre-test. My null hypothesis would be that mu d is equal to 0, that there is no difference before and after. And the alternative would be that the difference is greater than 0, so that the post-test scores are going up. Our alpha value is going to be 5%. And my degrees of freedom is n minus 1, which would be 12 minus 1, which is 11. Plan. We do have paired data. The memory test was given to the same subjects before and after the chess program. Random, it was stated that it was a random sample. 10%, 12 is less than 1/10 of all sixth graders. And normal, we cannot do a central limit theorem here, so we have to make a normal probability plot. And we're going to do a normal probability plot of the differences. So I'm going to put the pre-test scores in list 1, the post-test scores in list 2, and then in list 3, I'm going to do L2 minus L1. Remember, you have to go to the top, highlight list 3, and click enter, and then put the rule in. And so my normal probability for that differences is fairly linear, so a normal model is appropriate. We're going to say what test we're doing. So we are doing a one sample, a paired t-test. T is equal to x bar, my sample mean, minus mu, my population mean, divided by my standard error, Sx, over the square root of n. So T would be 144.58 minus 0 divided by my sample standard deviation, over the square root of n, which was 12, which gives us a test statistic of 4.564. I'm going to draw my t distribution with 11 degrees of freedom. 0 is going to be at the center, and I'm going to go to my test statistic, which was a t-score of 4.564. And I'd be shading above, but there's really not much to shade because it's so far. It's almost 4.5 standard deviations above the mean. So my p-value is very, very small, 4.057 times 10 to the negative fourth, or 0.0004 about. My conclusion would be we reject the null hypothesis because our p-value of 0.0004 is less than our alpha value of 0.05. Therefore, we have sufficient evidence that the average difference between post and pre-memory test is greater than 0. All right, a match pairs t interval, so we're going to complete the interval for the same data set. We're going to do this as 90% because I had a 5% alpha value, and it was a one-tailed test. That means I had to have 5% on either tail, which means I'd have 90% in the middle. So I'm going to do a 90% confidence interval. State mu d is the true average difference on the memory test, post minus pre. Confidence level is 90%. Degrees of freedom is 11. Plan, we're going to go ahead and say conditions are met since we did them in the previous example. And we're doing a one-sample paired t interval. Do, our confidence interval is our statistic plus or minus our critical value times the standard error of our statistic. So we have 144.54 or 583 plus or minus t star. So t star, we would do inverse t in our calculator. Our area, if we are doing 90%, that would leave us with 10%, which leaves us with 5% on one tail. So the area would be 0.05, and our degrees of freedom was 11, and we get a t star value of 1.796. Our standard error is 109.74 divided by the square root of 12, which gives us the interval 78.691 to 201.48. And then our conclusion, we are 90% confident that the average difference in scores on the memory test before and after the Ttest program is between 87.691 points and 201.48 points higher. All right, so this example, a manufacturer wishes to compare the wearing qualities of two different types of automobile tires, A and B. For the comparison, a tire of type A and one of type B are randomly assigned and mounted on the rear wheels of each of 5 automobiles. The cars are then operated for a specific number of miles, and the amount of wear is recorded for each tire. Do the data present sufficient evidence to indicate a difference in the average wear for the two types of tires? So this one actually is not a paired. We can't do a paired test. Even though this is set up like a match pairs experiment, right? So remember what a long time ago when we learned about the different experimental designs, this would be like a match pairs experiment because it's going on the same car. But because I have two different populations, tire brand A and tire brand B, I can't find the average difference. I'm finding the difference in the averages. So if I wanted to follow through on this problem, I'd have to do a 2-sample t-test and a 2-sample t-interval. But we're not going to do that. All right, go Seahawks.